Well, hello guys, here Mr. G with another video. This time we're going to be solving another question on electric circuit. This one is coming from an informal assessment on electric circuit developed by Professor Rodriguez this year. We're going to be answering this question. There are two types of tests that Professor developed. One of them is an informal test and the other one is a challenge informal test. We're going to try to answer both of them. Each of them will have like 3 questions. It's not too big, and we'll see how it's going. So we're going to start with this one, and we will start with question 2. Okay, question 2 say in the circuit diagram represented below, the battery has an EMF of 18 volts. That is the first important note to take there. The EMF is 18 volt and no internal resistance. So there is internal resistance in the circuit and is unknown. The resistance of the resistor R is also unknown. You don't have resistance R with which S open, the ammeter reading is 2 amperes. So they have the current, they're giving us the current which is 2 amperes. So if we write here, this current is equal to 2 amperes if this switch is open, as you can see there. So in that case, we only have one resistor which is in series with the light bulb. So the first question says state Ohm's law in words. And what does the Ohm's law state? It states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So potential difference is directly proportional to the current. That is the very first important of this part of the definition. But it's not the only one. You have to say that this is happening at constant temperature. That conductor temperature doesn't say. Calculate the resistance of the light bulb if the power dissipated is 12 volts. Okay, and the last question, the last video we did, we answered a question which was exactly like this. We have to calculate the resistance of the light bulb, and for that we have the following. They give us the power. So for this light bulb, we have that the power is equal to 12 watts, and we have that the current is equal to 2 amperes. It's given to us and the current is the same. We're looking for resistance. Guys, note this is happening only because this switch is open. If the switch closed, some of this stuff will change because the current is going to be different. However, the resistance of the light bulb will stay constant. So if you go to the formulas, which in this case, in this test, you can see what question we're going to answer later on here. In the test, if you go to the formulas that you need on electric circuit, the questions of power are here. This is for power. So what question can help us according to what we have? The one of current that have that relationship there. So we go back here to the question that we are answering there. We are going to write the formula. Power is equal to current to the power 2 multiplied by resistance. Power is 12 is equal to current, which is 2 square, and the resistance is what you are looking for. If you rearrange this formula, you have that this 12 divided by 4 equal to R, and therefore R is equal to 3 ohms. So that is the first part of this question. That is question 2.2. Question 2.2, the part of this question. Next question, calculate the internal resistance of the battery. So we have to calculate the internal resistance of this battery, and it's quite simple. It's quite simple. So let's have a look how can we solve that question. Let's first of all note that this circuit have 2 resistors externally, which is the current flow in this direction, guys. You have this resistance, the current go on, it does not flow because this switch is open there. So it's go this way here. The second resistance will be the light bulb, and then obviously it have the internal resistance there. So all the circuit is in series as long as this switch there is not close. So what we can use Ohm's law for the whole circuit. Where is the formula? Right here is the formula you are going to use, guys. It's quite simple. You just have to go to the formulas because you have everything. This is question 2.3. So let's write here 2.3, and here will be enough space. EMF is equal to current that multiply the addition of the external resistance. I'm going to write external plus the internal resistance. But as long as you use a capital R, that is already the external resistance, guys. So the EMF is given to us and is 18. We are going to substitute as we have the formula. We are not going to rearrange anything. So this one is 18 is equal, the current is 2 amperes. I'm going to open bracket, the external resistance is the resistance in series here of the light bulb and the resistor. So let's write here external resistance is equal to R of the light bulb L, which we did calculate, plus the 4 ohm. So if you substitute, this one is going to be 3 plus 4, it is 7 ohm. This one is the external resistance which we are going to substitute there. We substitute in that external resistance there. So when you substitute here, you got that this one is a 7 plus small r, because you don't know it. Guys, this is simple math. So let's do it anyway. Is 18 is equal 2 times 7 is 14 plus 2 times r is 2r. So now when you rearrange this one, you have that is 18 minus 14 equal to 2r. So you solve this one. 18 minus 40 is 4 divided by 2 is equal to small r, and then guys, small r is equal to 2 ohms. We have now, we cut the internal resistance of the battery. That one is the answer for question 2.3. And to finish this question, they say when the switch is now closed. So let's go back to the circuit and let's erase a little bit all this one here. Remember, if you follow, take a note, take a ruler and a book and write the notes there. So now in this condition, they close the circuit. So if they close the circuit, note that the current will split. So current will come all this way, pass through, and when it got to this point, the current split in 2 parts. Okay, so if the switch is closed, how will the external resistance be affected? They're talking only about the external resistance here. External resistance be affected. Write down all increase, decrease, or remain the same, and they, guys, don't want to explain this. To me, could be the most tricky question on electric circuit, the one when you have to explain what happened if you change the circuit in any way. So now what is happening here for the external part of the circuit? So we are going to work only with the external part of the circuit. And we go back to one of our previous videos. There is a note, guys, that I was just looking for it. If you go there, you can see here in the resistor say the total resistance of the circuit decreases as you add more resistors connected in series. Now in this case, this is referred to the external resistance, because internal resistance doesn't change as long as you change the battery. So in other words, because you increase the number of resistors in parallel here, there is more path for the current to flow, therefore the total external resistance will decrease, and that is the answer for this specific question. That is the end of question 2 and will be the end of the video. I'm not going to make long videos, it's going to be one video per question. I hope it helped. If it helped, please thumb up, subscribe for the channel. I'll see you next time. Mr. G here.